Assalamualaikum warahmatullahi wabarakatuh. Now, our group, which is group number 31, will talk about our science presentation, which are type of force, measurement of force, the effect of action of force, and buoyant force. And our group members are Muhammad IRFAN bin Matsih, Muhammad AMIRUN bin ZULKIFLI, Muhammad ARIFF bin FAUZI, NURFARISYA binti ZAINUDIN, BINTI.
There are 8 types of force. The first force is spring force. Spring force means a restoring force, the push or pull a spring exerts on an object. This is the example. The second one is buoyant force. It is the force that has in the water to make an object that landed on it floats or sinks based on the object mass. The third one is gravitational force. It means force of attraction between all masses. Next is drag force. Drag force means mechanical force generated by a solid object moving through a fluid. This is the example. The fifth force is applied force. It is an applied force to an object. The sixth force is tension force. Tension force means the pull exerted by a string or rope when attached to an object. The seventh force is magnetic force. It means it's like gravitational and electric force, but it has a little bit different, which is its potential and momentum energy. The last one is frictional force. Frictional force is the opposing force which acts in the opposite direction of the movement of an object.
So for the next slide, I will speak about the effect of force. Okay. Force can change the shape of an object. As you can see, a plasticine becomes flat when it's pressed. A sponge becomes smaller when it's squeezed. Okay, next, force also can change the direction of an object. For example, a footballer uses a force to change the direction of motion of a ball, whether it's left, right, or middle. Lastly, the effect of force also can change the velocity of an object. For example, a car suddenly stops or start to move. That's all for my slide. Thank you.
I'm going to tell you about how to measure a force. Okay, first of all, a force has both magnitude and direction, making it a vector quantity. It is measured in the SI unit of newtons and represented by the symbol F. The original form of Newton's second law states that the net force acting upon an object is equal to the rate at which it's. Last but not least, we can measure the force using a spring balance. The spring balance can let you know how much force that you need to use.
So this is the example of spring balance. So for the last slide and the last subtopic that we get is buoyant force. So you have been told that the meaning of the buoyant force. So buoyant force is an upward force that opposes the downward force of gravity. So the buoyant force is an upward force, which is here, and the downward force is the gravity force here. Okay, so the picture is not so clear, so I'm gonna show you another picture. So this is the picture that I want to show you. So here is the mass of the object. Here is the mass of the object. I'm sorry. Here is the mass of the object, as you can see, and there is the density of the fluid. The density of the fluid, I'm just gonna tell you, the density of the fluid is always 1,000 kilogram over meter square. I'm sorry, meter cube. Okay. Okay. Why is some of object is float in the water while some are sink? You cannot say it is because of the size, because a small rock is actually sink in the water, while a big ship is floating in the water. So I'm going to explain this statement by using Archimedes' principle. So a submerged object will experience a buoyant force equal to the weight of the displaced fluid. So it means I can say that an object will float if it is less than the fluid. So for example, this object is less dense than the fluid. So the force it has a bigger force than the weight. So the force will push the object to the upper surface of the fluid. So the object will sink. So if the object is more dense than the water, so it will submerge. I have said about ship earlier, right? So now I'm going to explain why is ship floating. So actually, ship use some of metal to build the ship, and of course the metal is heavier and more dense than water. But why does ship float? Actually, it is because there is air. Because the metal is shaped so that it has a lot of air, which is less dense than water inside the ship. So the average density of the ship is actually lower than water. So the ship floats. But let's say there is accident, or maybe you have watched Titanic, right? The ship is crashing the iceberg, and the hull springs has a leak. Then it will fill up with water. So there's no more air to lower the average density of the hull. So the shape sinks, like in this drawing and picture. Now I'm going to show you the formula to count buoyant force. So the formula is actual weight minus the weight in the water. So let's say when we put the object in the weight machine in the outside of the water, it is, let's say, 10 Newton. And when we put the weight machine in the water and we put the object on the weight machine, it is 2 Newton. So you have to minus 10 Newton with Newton. So it will be 8 Newton. So this is the buoyant force. Okay. That's all from us, and thank you for listening to our presentation. Assalamualaikum warahmatullahi wabarakatuh.